What is hardness and rigidity? Hardness is the resistance to pierce or puncture a material, while rigidity means the resistance to deform a material. The words rigidity and hardness may look like synonyms, however, they are not. According to material science literatures, rigidity means the resistance to deform a certain material. Rigidity can also mean stiffness, both directly related to the modulus of a material. Higher the modulus, higher will be the rigidity or the stiffness. More difficult will be to deform, cause a permanent deformation to this material. Hardness is the resistance to pierce a material. Quick and practical way to evaluate hardness of two different sample materials. You can do it right away. Rub one sample to another. The material with higher hardness will scratch the other with lower hardness. A material with high rigidity will present a high modulus measured by an universal testing machine. This machine might have different sizes and capabilities. This will depend of the type of material analyzed. For metallic materials, for example, for alloys, a very powerful UTM, universal testing machine, is required. While for plastic films, you can have a proportionally smaller one. Now, this is the representation of a universal testing machine, very common for analyzing physical properties of various types of materials. A sample specimen is fixed in the lower hook. The upper hook pulls the test specimen until its destruction, measuring various values including modulus and the rigidity, and therefore generating tensile deformation curve. This tensile deformation curve I will be able to explain in another video. A material with high hardness will present a great resistance to be perforated. To measure a material hardness, it is used a Rockwell hardness tester or a durometer for softer materials such as rubber and plastics. This is the representation of a Rockwell hardness tester. A diamond or steel pointer pressure the sample material upon piercing it. This material have to be very hard, much harder than the materials that we evaluate. If you want to evaluate, for example, hardness of metallic materials, alloys, you need something much stronger than the material itself. A dimensionless value called Rockwell hardness will be measured. Higher the value, harder the material will be. So if the more value you have in this test, it means the material will have high hardness. This is the representation of a durometer with Shor scale. This is an idea of the Shor scale from A to D. For basically most rubber and plastic materials, you can use the scale from A to D. Okay, nowadays we have been developed, up to this date, we have developments of various polymers and thermoplastic materials that might have much higher hardness and therefore other scales for sure up to more letters, maybe E, F, G, K, for much harder material, plastic materials. But for most common applications, polyethylene, rubbers, elastomers, you can have from short A to short D to measure most of the market samples that we have nowadays. The principle is more or less the same as the Rockwell tester, but the equipment, the pointer of the equipment is not so hard as we have for the Rockwell. Thank you very much.